Hello and welcome. I'm Bill Wake. We're working on a project. It's a tune similarity analysis tool, and we've got at least a little bit of stuff working for notes, and we're trying to work on keys. We've done something called a Parsons code, which analyzes a melody. We've taken some shortcuts in the notes, and for 99% of melodies, it won't matter, but I want to get these keys in place so that it works as it should. And then I want to do some work on making them nicer. But today we're focused on keys and notes. We're not going to do every bit of every key, but we'll do at least the major ones so we can get started on things. All right. And all right, where we left off. I don't think this is ideal code really, but we are working on this function. Make accidentals is going to take the name of a key, like C or C sharp or F, B flat, some key name, and it's going to tell us the sharps and or flats that get involved in it. And this part creates a dictionary that goes from the name of the key to the note values that have sharps or flats. Okay, we only did F. The flat keys, we only did F. And the keys are coming from this. This is the ABC notation standard. I think it's 112 pages printed out. It's not tiny. Okay, accidentals. Well, go ahead. Let's start here. I think somewhere. Okay, the key field. Clefs. I don't want to mess with that really. Let's go back to the index. K's, key. Oh, not alphabetical. Interesting. All right, here we go. This table is sort of standard notation. Most music, like popular music from, kind of Bach to the, current days in popular music anyway. There are flats, sharps and flats, and if you have 0 through 7 sharps, they come in a particular order, and you can have 0 through 7 flats, and depending which key you pick, you get that. Okay, so key of D is 2 sharps. That's a very common key for a mountain dulcimer, which is what I play. And but if you're in G flat, that's 6 flats. Okay, now there's the major scale basically. It's just do da 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 da. The do re mi that you probably learned along the way, even if you're not much into music. And the notion, there's the notion of a mode, which is sort of, and I guess I would say an arrangement of notes from a scale or a choice of notes in a scale. And the mode, one way to think of them is kind of starting on a different note, but notes aren't equally distant apart. So if you start on a different note, you get a different pattern. And so if I start on A and I'm playing A, B, C, D, E instead of C, D, E, F, G, okay, I get one pattern. If I start on D, I get a similar but not identical pattern, and so on. Every starting point gives me a different pattern. Each of those patterns is one of the classical modes: Ionian, Aeolian, and so on. Okay, so basically this defines the bulk of keys that you'll run into. Certainly for me, I'm interested in old time tunes, ballads from England, in the last 500 years or something, things like that. And these mostly cover that. Now, ABC, it lets you do all these. It also lets you just create your own. So you could have F sharp. Here's D Phrygian, okay, is it 2 flats? Yeah, D Phrygian. Okay, you could take those 2 flats, which are B flat and E flat, and you could add an F sharp and get another mode. Okay, a mode common in klezmer and Arabic. Okay, not very common in Western music. But you can explicitly choose the notes you want to modify an existing mode. You can just define all the notes yourself if you want. There's a couple modes used by Highland bagpipes, and traditions about how do you write it. Do you have a key signature? Do the notes go up or down, and so on. Okay, that that's all possibilities in ABC, and then you can also change clefs, and I'm really not going to get into that at the moment. Okay, but what we did yesterday was we got the one letter names, F, C, G, D, A, E, B. All right. I'd like us to make sure those all work, and then go on to do F sharp, C sharp, and these flat ones. Okay. And you write them with a B for the flat and a pound sign for the sharp, even though a sharp is actually written a little, normally it's drawn a little differently than what you see here. Okay. Okay, so let's go back to code. Make accidentals is really making a table that maps from key to a list of sharps and flats. Okay. And we have a parser. Right now, the parser only handles one letter things. But if I go back to the spec here, you can follow them with a sharp or a pound sign or a B. Okay. And we haven't done that. Okay. It's funny that this as reading it as a pure standard, it's not quite up to that level. Okay, the mode should be specified when no mode is indicated. Major is assumed. So usually, like words like that, I don't know. In the standard, it's like the, I don't know. There's not really a should. It's like either it's allowed or it's not allowed. It's required or not required. I think there are a number of things in this notation. It's grown up over time, so it's accumulated that stuff that's a little weird. Same thing here. You specify the key C sharp or B flat, but down here when you're trying to add extra accidentals, you're using the pound arrow key. The little circumflex means sharp, and you put it in front instead of afterwards. So you got an inconsistency in the way we write the notes as well, for no reason I understand, but that's me. Well, I can guess one actually. B is a legal note, and so if you allow a B, you don't know if you're writing an A followed by a B or an A flat. So answered my own concern. Why it's okay here, I don't know, but it is. Okay, so what I want to do is let's go back to the tests. Let's make sure I'm doing something related to what I'm broadcasting that I'm doing. Parse remaining keys, add accidentals. Okay, yes, I think that would be a good thing. Make note, understand keys. Let's parse. Let's add modes as another possibility. I don't know. I don't know if I want to do this part now, but we need to parse modes for keys. Parse. Maybe this is like key. Parse modes. That's one thing you could do. Key. Parse explicit notes, which interesting. Okay, and key parse HP and HP. Okay, that's all stuff you could do for key. For us, I don't think I care for the most part. I mean, this is more of a notation thing. It assumes the key is two sharps. It doesn't write it, so I don't know. We'd have to see about it. It probably does affect some things. These explicit notes for keys are pretty rare in the kind of music I'm looking at. They're legit, but they're rare. And the modes, that gets used a fair bit. I play dulcimer, and it's got one of these uneven scales, and so modes show up for uneven scales very much. And it's pretty common to play Mixolydian songs. There's a number of those. There's a bit of Dorian, and there's occasionally, just occasionally, like Phrygian or something like that, one of these other keys. Major, minor, of course, are the bulk, but they do use modes. So I do have music that does that. The other thing I want to go to, and I think I'm gonna, once we get the notes in, I want to do this. I want to make Parsons code for a whole file, okay, which means we have to understand where each tune starts and ends, okay. And I also want to draw Parsons codes, okay. So the true form of them, the defined form is star, up, down, or the same, repeated, okay. But you can also draw something like this. I need an overstrike, but that's the same. Here's a down. If I went down further, it would take multiple lines, okay, and I might go up at that point. Well, let's go down one more, and then up again, okay, and then maybe I stay the same, and then I go up again after that, or something like that. We need to draw. I want to draw the pattern of this thing. Actually, maybe I'd be better off with underscores above it. Yeah. Okay. So kind of depends on the note, what makes sense. Okay, I don't know about that star. Okay. So at any rate, I want to do something like this with these curves so you get some sense of what's going on. Okay. So I could say the song goes up, it stays the same, it goes down several times, up once, stays the same, and goes up again. And if I were to index by these, it would be nice to find if there were a similar song that was, let's back and type, star, U, D, 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 R, up, R, up, okay, or whatever. If something's had kind of a similar profile, it would be nice. Okay, so I'd like to draw Parsons codes, and I'd like to sort the file, sort the analysis by Parsons code. Okay, so if I want to find similar melodies, it would be nice to do that. It'd be nice to have this even stick figure drawing, and go from there. Okay, so I think we'll get through this first two today. If we can, we'll start the other. This one's interesting to me because I have the notion of where do you start. This is the line. Like if I were doing this to show a particular song, I'd like to show, one Nos Galen 1716, if that's the title. I'd like that first line of this to match the first line of that, and then I'd like to have the Parsons code beneath it as underneath the graph. So I think there's a little bit of a sort of box language we're going to define that has sort of a focus point, and we want to align focus points, and we might have to put blank lines over here and stuff. So it's got some little interesting twists, I think, in doing that. But I would probably focus on Parsons code before going in and doing the rest of the modes. At any rate, if I don't start, we won't get any of them. All right, let's go to ABC parser tests. Okay, so we got single letter sharp keys, single letter flat keys. Let's just do some more sharp keys. Other sharp keys. Okay, and we got this check sharp key thing. That's handy. And let me go back here. Okay, so we need F sharp and C sharp. And I don't know, again, that you're not required to be a music major to do this, but F sharp and G flat are really the same note. So there's sort of like two different ways um, to write this thing. Okay. Similarly, D flat is the same as C sharp, and C flat is the same as B. So it's interesting to me that we can kind of wrap around that five flats is the same as seven sharps and stuff like that. There's something called the circle of fifths that's sort of a music theory way of looking at things that says, if you step around by fifths in the tuning we use these days, you eventually get back around the circle to where you started. And this is kind of proof of that. Even here, this C sharp, you could write it back as flats and keep going and you'd be fine. Okay, F sharp, C sharp, I said. Okay, so F sharp. Okay, so the rule is these go up by fifths, F, C, G, D, A, and then is E. So E sharp is really F natural, and then sharp that is F sharp. Okay, it's a little weird. And the next one is C sharp. E, and then it adds B. Okay. Now this is going to fail. What does check sharp T do? Okay, it parses. Okay, I'm going to... Two failures. That's not much of a message. It's really not much of a message. Okay, down here. Tonic C natural 4 accidentals. The result is not equal to C sharp 4 with F, C, G, D, A, E, B. Okay. And one of the things you do as a music major at some point, you learn this list forwards and backwards. B, E, A, D, G, C, F. F, C, G, D, A, E, B. Okay. And the F sharp key signature failed. It only looked at the F. Okay, so I think the name of this check, it's not tonic. It's really key name. Okay. Same thing here. And it's passing in a string, so I'm comfortable passing in a string. Okay. Right. So, check key signature, and this one should also be key name. Okay. Check sharp key. All right, so we parse ABC parser, the key name, but here it only goes up through A through G, and it doesn't account for that sharp that's a legal character after it. Okay, now adding to it is going to change what goes on with build key. Okay, so the value of this thing, we'll have to append it, and it is the pound sign. Now it's actually optional. Okay, so the K colon we don't really need to keep around. The ampersand, they're not really required to match. I think it's build key that's causing the problem here. Let's confirm that. Yeah. Okay. We're going to get a letter for this one and an optional letter for this one. Now, build key is not in on the situation here. Build key assumes it's just got the key name character. Okay. Now we need to add in the accidental is a character optional. Okay. And let's make that like that. Okay. This function is called with the result of the parse, wherever that got off to. Here. So instead of just getting A through G, it gets A through G plus an optional character. Okay, I think it's not complaining anymore, so I believe that's good. We'll do that, and now it matches legally. Okay, still not right. Okay, C4 is not equal to C sharp. Okay, and the reason is, oh, okay, yeah. So if it doesn't recognize a key, it defaults to C. So that's why this one is that. In this case, it recognized, I think it recognized the F, which has one flat B flat, and so it thought, oh, I'm going to be F, but it's F sharp. Okay, so we have to do something with it, I guess is the point. Okay, so here, the tonic, let's give the key name. The key name equals oh, interesting. Well, the key name, this is the problem. Okay, I think maybe this note is wrong. The key, I don't think the key itself is a note. Okay, so let me back up. I think that ought to be a string. So let's undo this test and do some refactoring instead. Okay, so let's say ignore test. And I know there's a way to do it in here somewhere. I don't know. I guess it's not a test now. There's an environment way to do this. I don't know what it is. But I'm just happy enough to do this. Okay. Test should all run now. Let's make sure they do. Oh, if I were to do that. Okay. So I think my claim here, I'm going to take that comment out just because we'll get there eventually. This is not right. The key, because we're barely saying F sharp, the key of F sharp. We're not giving an octave. I mean, we're yeah. I just think that's wrong. So I think we need to make key hold a string, which is the key name, but not a note. Okay, so I'm gonna. We don't use this in a lot of places, so I'm just gonna modify it. And let the compiler drag me through. Okay, so let's find key tonic. I'm gonna do this. And even tonic is not really right, but let's get it through first. There should be some tests. Cannot convert note. Key tonic note. Accidentals. Okay. I do think there'll be a test or two, but where are you? Okay. Let's just keep the tests on the left. Okay, key name. I think key name is actually a better name for that too, because HP is not a tonic. Okay. Make key no a key name. Not treat a note as the name. Now the real thing may be that I need notes that don't have octaves and don't, they know their sharpness and all that, their accidentals. I don't know. It's hard to see the way through when you've got limited pull as we do here. The pull for me here is I want to take arbitrary files and feed them in. So that means I got to support more and more of the full capability. But the simple cases don't need it. So who knows? All right, let's go to key. I'm going to change this name to key name. Maybe just name. Yeah. Okay. And that's its accidentals. Okay. That should be no problem. Oh. Okay. That should be a problem in several places. Oh, it didn't fix the test. It only refactored over here. Ugly. Okay. Refactor key dot tonic goes to key dot name. Okay. Let's see. Now I want to look at our parser. Yeah, I'm feeling like we don't. Some of this. Well, the thing is, string to note. It's like the string is defined in the input file. The notes are domain objects, so I'm mixing a little bit. I don't think that string is necessarily the wrong string, but okay. So now do I want to tackle this? Okay, so now I have string to note. That's better, I think, because I can have my C sharps and all that. Okay. Let's uncomment those tests. Okay, now these tests should fail again. Yep. Okay. I think they changed the way Xcode works. It used to just tell you this at the place. Now you got to go find the thing. Okay. Here's C, accidentals, key name, C sharp. Yeah, so it's basically not prepared to recognize the C sharpness. Now that's a legit key, so it really should be in here. Okay, so the sharps F, C, G, E, A, E, B. Okay, there are only 7 choices because we have notes A through G, so that list is complete there. These keys are not a complete list though, because B should go to F sharp, and I think that should make that. Oh, I should do C sharp first. No, I'll do F sharp first. That should make that last test pass. Oh. F sharp failed. Key name accidentals B flat 5 is not equal to. Okay, so somewhere we're not passing the name along. Is that in my parser, I guess. A.G, we match. What's build key producing? What's down here? Oh, it produces the actual key. Okay. Oh, right. Yeah, we're just passing the tonic in, and it looks up C and F and says, okay, let me just give you that. All right. So now the string, okay, the key name is more complicated. It's going to be string of tonic. I guess we can plus, and then accidental, the string of the accidental, and if that doesn't exist, empty. Okay. What's the message here? No exact call to initializer. String accidental. Well, no, let's do it this way. If it's not nil, then key name dot append. I don't know if I can just do accidental or if I just stringize it. Return. Okay. So we get the tonic name, the accidental. If it's not there, we do nothing. If it's there, we append it. Then we use that to look up. Okay. Now I think F sharp should work. Of course, I thought that last time too. Okay. Key name F sharp, accidentals B5. It's still looking for F. That's interesting to me. Okay, so key name F sharp. That part came through. Okay, let's go find the lookup. The key constructor. What? Key. Wait a minute. Where's build key again? Okay. Oh, accidentals for tonic. Okay. Tonic. No, it should be accidentals for key name. Okay. And then that only takes characters. Now it needs to take strings. This is key name. And there's no need to string a string. Okay. So we're promising C will always be in there, and if it's not, then we're going to take one. We'll default to that. Okay. I don't know if you believe me, but now I expect one to pass, one to fail. Okay. No trouble believing I expect that, I'm sure. All right. So this one, C sharp, that works. And, well, is that? what's going on? Let's go to our dictionary. F sharp. Oh, F sharp worked, C sharp didn't. Okay, yes, that's right. It found the key name fine, but it didn't find any accidentals. It just defaulted to the key of C stuff. Okay. This one now needs, we just need to add it to the list, really. C sharp. Yep. Okay. So this covers all the sharp keys. 1, 2, 3, 4, 5, 6, 7 sharps. 1, G, D, A, E, B, F sharp, C sharp. Okay, that's all the sharp keys. Now the flat keys. Okay, let's check this in. Handle all major sharp keys. Okay. The minor keys. All right. This is. The funny thing is. Okay. Notice this one: F C G D A E B. If we let things wrap around, F C G D A E B, okay, it's telling us they're the same thing in the backwards order. Okay, so here it's G D A E B, and this one is G D A E B. So going up is going this way is decreasing the number of flats, and this way is increasing the number of sharps. There's a deep relationship there. So this list, F with one flat has B flat. B flat with two flats has B flat, E flat. With three flats, B flat, E flat, A flat. So with flats, you kind of look to the next flat, the next key to give you the flat names. But B, E, A, D, G, C is the backwards order of this. B, E, A, D, G, C, F. Okay, so these aren't sharps so much as they're well, they're almost like we call them fifths, because F, G, A, B, C, the five notes between F and C, is a fifth. C, D, E, F, G is five notes as a fifth. G, A, B, C, D is five notes as a fifth. They're all separated by fifths. Okay, but they're not all the possible things. They're only some of them. I'm going to call these. It's really, we talk about the circle of fifths, that if you keep going, you get all the way around. We're only doing these simple notes, but I'll call it sub circle, or maybe just fifths. Notes by fifths. Okay. I think that's okay. Undo this. Sharps. I think I should make the separate assignments. I think this should be notes by fifths, and then I should say sharps equals notes by fifths dot map. Okay, that should be a neutral. Whoops, needs a let. Should be a neutral. Darn it. Is it still complaining? No. Okay. Split out notes by fifths. Okay. All right. Now, this one maybe its own thing. The sharp keys. So a thing to notice here is this is the same thing shifted. GDAEB, starting here, GDAEB. They really are the same. And I don't know. It's like how much domain do we want to build in? But there's a duplication there for a good reason, because the key names correspond to kind of two sharps behind, where the flats was one flat ahead. The sharp keys. Okay, I'm going to say, like, given this, the sharp key signatures, well, let's rearrange slightly. Okay. If we map the notes by fifths, we get those. And this mapping is actually not really fully accurate. It's not always a 5. Sometimes it's a 4. I don't know how much that's going to matter. Okay, but this stuff, all right, this to me, like, that controls it, and okay, the sharp keys, I don't know. Oof. Maybe it wouldn't hurt. It's like I want to take a slice of it and just slice off the same thing. Let me extract it, and then we'll see what we get. Okay, come on. Sharp key signatures we need is an output. Okay, we'll do it the manual way. Produces well, what's the type of this? It's a pair, I think. Yeah, strings and arrays of notes. Okay, produces a map of string to array of note. Okay, and it's all that. And then we'll return sharp key signatures. Okay, so make sharp keys. I should be able to call, I should pass in notes by fifths, is notes by okay, string to array of note to return type string. Okay, I guess it's pairs. Pairs of string note. Okay, so this okay, that should replace this. I don't know if I'm shrinking my bulk enough with that, but that should be neutral. Can I cut that? Well, we'll keep the F key. Okay, so it's still neutral. We extracted a method. Okay, now the way you produce flats is very, very, very similar. And let's see what we got to do. Okay, I'm going to call this make flat keys. And let's put some tests in. ABC parser tests. Okay, check flat key. Single letter flat keys. Okay, let's move this one up. And this is other flat keys. Okay, and we'll check flat key and flat key. Okay, flat keys, B flat, E flat, A flat, D flat, G flat, C flat. Okay, B flat. Check flat keys. Okay, it makes flats out of each of these. Good. Okay. Calls check sharp key. That can't be right. Something's wrong. Check flat key should give back. Okay. Let's straighten this one out first. Single letter flat key should be check flat key. F should have B flat. Okay. And in here, make accidental, it hard codes F is B flat. Okay, does this test still pass? B flat is A sharp. That's weird. The problem is this circle of fifths thing can mean that things match going around. Notes by fifths, keys, flat. Okay, I'm not sure what went wrong there, but fix F test to look for B flat. Okay, other flat keys. I'm just gonna do the one for now. Okay, B flat should be B flat followed by E flat. Okay, B flat has two flats and they come in the order of B flat, E flat. Okay, this should fail because we don't do anything but F. It may. Okay, let's check flat key. What's going on? Check key name, expected, flat. Key signature, expected, accidental. Oh. That should be the accidental, not. Let's see where this is used. Too many places. But none of them in here. Okay, so. Yeah. Let's do this. I may mess up a number of tests. We'll see. Okay. Why are you working? How can you possibly work? Check key signature, key name, expected sharp or flat. Let's put sharp here and make sure this should fail. No. Key name. Okay, the key is ABC parser key. We'll look for key name. Okay, so we should get. Oh, no. Our parser doesn't know anything about flats yet, so there's something going on there with that. But how is it passing its test? That's the part I don't get. Okay. So we parse, and then we build up our list of expecteds. We take the expected strings. We expect these flats to be in there, and we create notes out of them off every expected item. And then we make sure the key has the key name we gave it, which I don't see how it does. And the accidentals we gave it. Okay, I'm going to take the word ignore off. Okay, the other one passed, right? Good. All right. Whew. All right. So here, this is match. Well, it's really a one of. Now, do I have a one of? I have one of for range. Match characters is set of characters. Oh, okay. I guess I can just do a set. Okay, so one of, let's do match. And pound or B. I don't know if that's quite the right syntax. I think I'm about to wrap it with set. And maybe I need parens, braces, brackets too. Seems odd I haven't used that before, but okay. If I do this, I think it still wants a, no? Okay. This is not going to work, but it's going to get a little bit closer. Okay, so the problem is now the key name is B flat instead of just B, and it doesn't find the accidentals we were looking for. Okay, so accidentals, where's our sharp keys? Okay, make flat keys. Well, this is, the flat keys are F, B flat, E flat, A flat, D flat, G flat, F, G, B flat, E, A, D, G. And is there, do we do a C flat? Yep. C flat. Okay, this is flat keys. Okay, 1 flat, 2 flats, and so on. Okay, now this, let's take the flats, note by fifths, dot reversed, dot map. Okay, so now we're going backwards. Notes by fifth is F, C, etc. So this is going to be E, A, D, G, C, and so on. Okay, so this is flats. Flat key signatures and flat key signatures. Okay, and for now, I think we're just doing these two. F, B flat. Okay, notes by fifth reversed. Notes by fifth reversed. So B is first. Okay, so F gets B flat gets B flat, E flat, and that. Okay. That shouldn't change anything because I didn't call it yet. Okay, make flat keys. Okay, and I've already got F in there, so I'm going to take this one out. And should complain nobody wants to use F key signature anymore. Whoops. No exact matches to append. Well, the signature should be the same. String note pairs, okay. Append, oh, contents of. Okay, I expect these two to pass. What happened? Move the instruction pointer, okay. You didn't just randomly stop there, though. Delete breakpoint? Maybe I bumped it. I'll continue. Okay, do it again. Clean. Okay, we have no need for this now. And this is now unused. Okay, immutable F key signature. Yep. All right. That should work so far. All right, so handle F and B flat with make flat signatures. Let's add more tests. B flat, okay. E, A, D, G, C. Okay, B flat is B, E. E flat is B, E, A. A flat, B, E, A, D. D flat, B, E, whoops, A, D, D flat, B, A, D, G, and then C flat, B, A, D, G, C, and F. B, A, D, G, C, F. Okay, these should all pass. Okay. A flat, C flat, D flat, E flat. Accidentals, nothing is not equal to B, E, A. Okay, what do we do wrong? Oh, I only put the two key signatures in. Yeah, okay. Let's take this out. B, E, A, D, G, C. Okay. I guess it's good. It means I wasn't pushing further than my code. All right, add remaining flat key signatures. Now, the keys. Let's call this accidentals. And let's call this key signatures. And I'm going to make it accidental. Okay, this one, let's call these accidentals. I may have to say something here. Let's add this one. These are accidentals. So what I'm doing is I'm making duplication worse. These things are similar, so I'm driving them to be even more similar. Okay, let's use accidental here. And the reason is I'm hoping I can make them more, I hope I can make them similar enough that I can just get rid of one of them. Okay. Yeah, so we refactor, rename, and introduce variable, so methods become more similar. All right, now if there's no reason I can't pass this in, there's no reason I can't pass this in. So let's do that here. Okay, so notes by fifths. Accidental of type accidental, and this is key names of type array of string. Okay, notes by fifths. Let's and key names. Okay. Now I'm making these explicit. This one especially because it's a duplicate. And maybe I should make this one explicit too. So you give me the notes by fifths, you give me the accidental you want to work with, and the key names you want to generate. And this is key names. Sharp keys becomes key names. Okay, so let's take these out. Make sharp keys gets called here. Notes by fifths. Accidental is sharp. And keys names is that. And let's notes by fifths. Accidental sharp key names. Okay, that should pass. Okay, and then make sharp keys accidental. I wouldn't have let me type that if I were them. Okay. Now I'm hoping flat keys works the same. Okay. Flat keys. Notes by fifths is notes by fifths dot reversed. Accidental is flat, and key names is this, and we're going to call make the misnamed make sharp sharp keys. Okay. If I've done this right, this works. Yeah. Okay, so now nobody's calling make flat keys now. So let's get rid of this. And let's call this just make keys. Notes by fifths is actually a bad name in a way because it's not really the notes by fifths. It's really the I think it's really order of accidentals. Come on. Okay. Order of accidentals. And I'm being picky about this because if you reverse the notes by fifth, they're not by fifths anymore. They're by fourths. F, G, A, B, B, C, D, E, E, F, G, A, and so on. They're all by fourths. So I don't want to call them by fifths. Now by fifth. That part is true. It is the notes by fifths, and reversing it does give you the order of accidentals for the flats. Okay. Next thing is, I think I want to make. Do I want the key names first? Like, what's the right order for these? I think I want to say the key names correspond to the flats in this order. So let's move key names first. Well, we want both those, right? Okay, key names, flats in this order. Okay. Key names. Sharps in this order. And my signature. Yeah, like you should be able to guess which one I want. Order of accidentals is now last. Key names is now first. Okay. And I call that move of making them more similar, I say harmonize methods and parameterize them and reduce to a single method. Okay, so we made them more similar. We pulled out the parameters to make them identical, and then we reduced to a single method, and then change argument order. Okay. That part's okay to me. This is coordinating those. Maybe this should come first or sooner. Kind of like do the sharps, do the flats. Well, do C, do the sharps, do the flats, and then append them all together. Yeah, I kind of buy that. Okay. So I think at this point we have successfully handle a major key A through G and followed by optional sharp or flat. Okay. I don't think we don't handle every possible combination, but we handle all the real ones. And yeah, I think that's legit. Actually, notice this. It can be none or empty. We don't have that. I mean, I'm definitely not doing everything this table can do. I've really only done this column with no first major column with no specification of modes, but I think it's kind of a good place. I mean, it covers the sort of 90% stuff. All right, parse remaining keys covering accidentals covering major keys. This is modes. Let's worry about empty. Empty or none. Okay, both are legal. Okay. Let's take this progress. That's good. Parse remaining keys. Good. We'll say major keys. Yes. Okay. I think we've done that. Some amount of music theory, domain knowledge in there. Good. Make note, understand key. Well, we've been going a while. So before we do that, let's take a break of about 3 minutes and we'll come back. And the thing we're trying to handle is note. Right now, you can tell it the key is in key. How do I say it? The accidental. There's an accidental that is in key, and in key means the key signature for the whole piece has defaults like F sharp and C sharp, and we should, if we see an F, we should treat it as an F sharp, and so we need to make an adjustment somewhere in here to deal with that possibility. So key of D, I don't want just a bare 2. It should actually be, C. Key of D, it's really C sharp. It should be a 1. It should be increased by 1 to account for the sharp. Okay. And in general, the full generality, it could be double sharp, single sharp, natural, flat, or double flat. So there's a lot of possibilities. Okay, anyway, we want to make it so if I ask, well, at least the MIDI, the note value, I should get the right value. I think the name saying it's C in the key is, and telling the key is still legit. But if we start comparing it, like comparing melodies, a C sharp sounds like a C sharp, whether it was written, one way or the other. Okay, so take a break, 3 minutes. We'll be back and handle keys and notes. And if that works, or if we finish that today, we'll move on to the Parsons code stuff. It's a toss-up whether it'll happen. See you in about 3 minutes. Hey, welcome back. Okay, so let's look at the tests. And let's see, we got a note. Let's move that one over here. Okay. So we basically check the simple notes C, D, E, F, G, and so on. We're looking at their MIDI numbers. Interesting. Well, right now our notes don't really handle sharps and flats. I mean, they know about them. I think we're going to have to be more sophisticated on this. Okay. Yeah, so what I think happens right now, the accidental gets recorded, but we just look up the note and we don't actually modify the note based on the accidental yet. Okay, so I think we want to do that. I think, we did these public functions names, but I think this is not really quite accurate for equality. I don't. Okay, yeah. Let me do that. So I'm gonna pull these in as functions. So a little refactoring before we go. I'll make a new extension. I want this to be is lower than. Note 1. Well, okay. Let's write a new function. Function is lower than, and note is a note, returns a bool. And let's return self is less than note for now. Okay, and then this one, and these have to be like that. Okay, they have to be outside, I guess. Let's have a public function is same pitch as. Again, note of note returns bool. And let's return self equals note. Okay. I think those should work, but nobody's calling them. Can we find the usages of this? It's a little awkward. Well, Parsons code is the place to look. Okay, so if note 1 less than note 2, we want to say if note 1 dot is lower than note 2, return up, okay? And if note 1 is same pitch as note 2, return R, and I hope that's everywhere. Okay, and now I'm going to inline these functions. Less than is really self.note value, note.note value, and this one is equals should still work. And now these functions are dead and should still work. Does not conform to equatable. I don't think I need it anymore. Key does not conform to equatable. Well, why does note not conform to equatable? Add protocol stubs. Let's add all these. Note value equals right hand side dot note value, and left hand side dot note name equals right hand side dot note name, and LHS dot accidental. I don't know why it doesn't write this for me. Oh, let me try this again. Let's take this out. Okay, and let's make this thing equatable. Note does not conform to equatable. MIDI note number is just an int. String enum this. I don't know. Maybe this thing isn't equatable. to pull this out. I don't know if it's the one that's causing the problem. Note does not conform to equatable. Well, it doesn't mind accidental. That's interesting. Okay, it synthesizes that one. Okay, let's ask. When does Swift automatically equatable? How about equatable? For a struct, all its stored properties must conform to equatable. Enum values conform to equatable. Without associated values, it's fine. Okay. I don't know the problem. Well, it's not that hard to do it, I guess. And I think I can put this a little lower down after the initializer. Actually, I think I'm going to make it a separate thing if it's going to be separate. Extension note is equatable. Take it off there. Okay. So we did we well we made note properly equatable now have is lower than and is same pitch as to compare note numbers. Okay, and this private constant, that's fine. Let's start checking MIDI note numbers correct for uppercase. I don't really care about uppercase for, let's say, natural note. This I kind of don't care about, but I guess I can leave it. Check this with in key. Okay. Now I want to check some other stuff. Let's see. All right, let's get these accidentals straightened out. Note is a string. Okay, let's do a function check MIDI note number. Note name is a string. Accidental is an accidental. And octave is an int. Okay. Now this thing can be this with accidental. All right. Whoops. Cannot find expected. Cannot find note. Note name. Note. Octave expected. Okay. Let's see. Okay, and then what we want to check then, the more full version, I want to make MIDI note is modified by accidentals. Okay, so we're going to call check MIDI note number. Let's just take good old C. And if we do sharp, let's do natural first. Natural octave 4, fine. And expected is 60. Okay. That should pass. Interesting. I'm getting a complaint, but it's still running. And the complaint goes away. Okay. Yeah, that test passed because C natural doesn't change anything. Okay, but now let's do C sharp. Should raise it by 1. That's going to fail. Okay. Half steps above C. Okay, so well, now I need to do a modification. Oh, secret numbers. All right. Well, I want to say somehow like let adjustment equals, and then if accidental is natural, it's 0, else 1. That's kind of a lie. All right, excuse me. All right, so this is a lie, but it's a lie that's enough to pass this test, I believe. Oh, if I were to add it in. Plus adjustment. Okay, so I'm looking up. Well, I can't really do it that way, can I? I've got to do it down lower. Okay. Note value plus adjustment. Oops, 2 pluses does not count. Wow. Oh, that passed, but some others have problems. Okay, interesting. MIDI note number is correct natural note. 61 not equal to 60. It looks like it's adding it everywhere, doesn't it? If the accidental is natural, it's 0, else 1. Oh, right. If it's in key, it's, yeah. So let's do var adjustment equals 0. Switch accidental of case natural or in key case sharp accidental equals 1. Okay, and then default, whoops, that should be adjustment. Adjustment equals 0 is kind of the default. Okay. 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 If you do double sharp, should go up by 2. That should fail, the other should pass. I think we can risk doing both. Flat should be 59. And I'm still saying it's in the same octave. That's maybe arguable. Okay, 58. I'm treating the octave as the musical, as the analytical thing, that if you wrote a note in this octave, whatever form you made it take, it's the same octave. You could also look at it as, hey, it's a lower note than the first note of the octave, so it should be below. All right, well, anyway, sharp is a 1, flat is a -1, and double flat is -2. Okay. Okay, so now if you pass it in, we account for it in the note number. The thing we're not adjusting, well, let's split this up. Okay. I think this is a better reflection of the current state of things. All right. Handle remaining accidentals for note values. Okay. That is good. Okay, so now we've handled the simple notes. If it's not in range, well, yeah, if it's not found in that list, then it comes back nil and it becomes a 0. Okay. I don't know. How to handle these. It's sort of like can't happens in the sense that if your parser's doing their job right, it won't ever happen. But the representation allows other names than A through G, and I'm not quite sure what we want to do. All right. That covers the note cases. I mean, that covers all the modifiers, but it doesn't really deal with the in key. What's the meaning of that? Okay. And so I think what we have to do is I think we want to say check key adds accidentals. I guess I want to say test instead of check. Key adds accidentals. Okay. So this one, I think we can use this version. Check in key octave is what's expected. Well, really, I want to say, well, this is actually a good chance to check equality. No, same pitch as. Okay. I want to say that if you create let note equal note with note name, let's do C. What's the stuff? Note name, accidental, and octave. C, in key, octave 4. But I don't say the key. I need to say the key. Now, I don't know. The ordering may be awkward. I really need to say this in the key of C. C, nothing. That's kind of what I want to do. And then I want to say assert true. Note dot is same pitch as. I want to take note C sharp octave 4 like that. Okay, key. Okay, should still be complaining. I don't know why there it is. Okay. I don't have an argument for that. And I don't know if let's do this. sorry, I want key of D. Accidentals. Oh, they got to be notes. Oof. Well, that tells me I should use an easier case. Let's use the key of G, and sorry, the note F is sharped in the key of G, which only has one sharp, which is note F sharp 4. Say 5. Well, simpler is going to be 4. Okay. I think that's okay. This doesn't accept a key yet, so let's make key of type key, but default is key of C empty string, empty list. Cannot be declared public because its type is internal. Okay, let's go to key public B. Yeah, this. Name accidentals. Okay. Now what? Name accidentals internal. Okay. Okay. What else? Init is init is internal, cannot be referenced by default value. Oh, I guess it's the implicit initializer. Okay. Public init name string accidentals of note is self.name equals name self. Okay. What's the issue? True failed, yeah. So this is a case where the equality is not equals, they are equals. Let note, let's call this note and key. Okay, and let's pull out this note. We'll call it F sharp. I guess I need to make them the same, don't I? F sharp. I think it's still going to fail, but yeah, this might have a chance of working. Add, sorry, true failed. Okay, so F in the key of G is not, let's say assert not equal. F in G and sure F in key, I think is a better name, and F sharp. Okay, F and key and F sharp, they boil down to the same note because the F and the key should convert to the F sharp, but they're not exact. They don't have the same. The MIDI value is the same, but the the note is not strictly speaking the same note. And I think, I mean, I'm making a decision here that this is the way it works, but I think this is the right thing to do. Okay, what's the matter? Okay, and in this one, I think the assert false not equal should be fine. I'm gonna clean. I don't know why it's building the iOS. It's internal. That's like an old complaint that I thought we got rid of. Note and key, that's legit. Okay, that's F in key is the same pitch as F sharp. Yes, that should be true. Okay, so the true one should fail. The not equals, sorry, this one should be passing, but it's not because we haven't written the code yet. This one should not, should also be passing, but we have written the code. They are not equals in the equality sense, equatable sense. Okay, note. All right, so there's my failure. F and key is not the same pitch as F sharp, but it should be. And the reason is this adjustment equals 0 is not sufficient. So I think what it should be, and this is the trickiness. Okay, the confusion. Let's see, where's key again? Let's go find that. Key and notes depend on each other. That's really. I think that may be why we're getting the error flickering in and out. They depend on each other. Let's put them in the same file. There's no way around it. Okay. Or I don't like the way around it. Okay, so I think what needs to happen is this adjustment equals 0 should really be asking the key. I should be able to say public adjustment for, and then I give it something, and it gives me back an int that tells me how many half steps up or down or 0 do you need to be with this key. Okay. And I'm going to return 0 for now. Okay. Oh, yeah, funk. Okay. Kotlin has fun. We have funk. Okay. 0. So I'm going to move this adjustment for is key dot adjustment for, and then what am I passing in? Well, I don't care about the octave. I know it's accidental is in key, so really I just want to pass the note name. Okay. And this is a note name of string, which I may grow to regret that. I'm already starting to. I just don't have a good solution. I could make my constructor throws, but then everybody that ever creates one has to worry about it, and that just really is irksome. I mostly just don't want people doing it. I don't think I can. I really want to say it's a string or even a character restricted to A through G. Okay. Adjustment for note name. I pass in the note name. This should all fail the same way, but everybody else should pass. So line 32 should fail. Everything else. Oh. Wait a minute. What is going on? P. Yeah, these things just flicker away. Okay, I guess it's just catching up. All right. So, note name. Okay, so now I know the note in the key. I know the accidentals. Okay. So, I want to say okay, I want to say this is like the weirdest thing. Let's look at key accidentals. I think this is F sharp. Okay, that's actually right. Okay, I think we want to find. Let's take the accidentals. Dot first where. Yeah, thank you. Nice. Okay. The note. I'm just going to use $0, I think. Okay. I'm trying to find the first one in the accidentals where the note name equals note name. Okay. And yeah, I am not done yet. Okay. Let accidental note equal. Okay, so this is either nil. If there's no such note in the list, like key of C has no notes in it, so you come back and say, I didn't find a note where it matched the note name. Okay, if that's nil, accidental note is nil, then we're just going to return 0. That much is clear. Otherwise, we want to return well, let's let accidental equal accidental note dot accidental. And I don't know if we are guaranteed. No. Okay, what? The type, well, really we know it's not nil, so this is safe. Type is accidental. Okay. Now, I don't know. I can do this. Default is 0, and if we get a sharp return 1. Okay, you raise it 1/2 step if it's sharped. Okay, I think that is correct. That everybody else is going to be okay. All right. So, note in key consults key signature for its adjustment. Sharps only. Now the place why I'm resisting, I guess, the accidentals I should be able to get them to tell me that. Okay, let's push it there right now. We know. Okay, I should be able to say return accidental dot adjustment. Okay, and that doesn't exist because I haven't written it yet. Okay. Return an int and that. Okay. This is the kind of thing that should be over here. All right. Should all work. Yeah, there you go. Self. Not getting far. No member adjustment. Accidental has no member adjustment. Value of type accidental has no oh, gotta spell it right. Should all pass. Shouldn't be beeping at me. Okay, that feels better. And I think I can inline this and be just as happy. Okay, so if the accidental node is nil, otherwise take the accidental from it and make the adjustment. A little bit of chaining, but I feel like it's okay. That should be no change. All right. Make accidental know its adjustment. And that knowledge feels very right to me, that the accidentals, double flat always means go down 2/2 steps. Sharp always means go up 1. Okay. I think we can say for sure that in key, I think it should be a 0. This is based on, well, we know it worked this way with a 0, so I'm just being explicit, but we're not going to call the adjustment, the key is never going to contain an adjustment that says in key. It's always going to be sharp, natural, double sharp, one of those. Not line 11, but any of the others. So this case really shouldn't happen. If it does, if your key says the key is in the key, I think a 0 is pretty plausible. If we could find a way to avoid it, I guess I would. Mostly we're avoiding it now by don't do that. And there's no mechanism in the user input to like force the wrong accidental or anything. Even when we handle these cases, like the explicit markings, there's no way to specify in key. That's a concept we're using based, well, it's sort of extracted from the way the K interacts with the actual notes, but it's not an issue. Okay, so this though, I would like to iterate over this. Let's make a check out of this, I guess. So we'll duplicate this method. And I'll call it check key adds accidentals. And we're going to want to call it, the note name is fine, the key is fine, F sharp. The key name is a little bit arbitrary. Right, that name field is not any, it's not consulted by anything. Okay, so I'm going to say this is a mystery key. That should still pass. Oops. Well, I haven't called check. Check key adds accidentals. Should be okay. Okay. Maybe test might be a better word, but it's not referenced by anything we're doing. Okay. This, however, is the accidental, so I want to pass that in. Accidental of accidental, and then I want to use it twice. Basically, we're saying if you put it in the key signature, it's the same. You get the same pitch as if you specified it directly, even though it's not quite the same note. It's the same pitch, so it's sort of a different kind of equatable. Same pitch, different note, strictly speaking. Okay, and this one now needs to pass in sharp, and the names should reflect FN key, F modified, F accidental. F accidental. Okay. I don't know. Is that effective note? Okay, but this should pass. And then double flat, flat, natural, sharp, and double sharp. So double flat, flat, natural, sharp, and double sharp. Okay, a couple of these will pass, most of them will fail. Natural should be okay with the default. Yep. Double flat, flat, and double sharp are not. And we can easily fix that. 1, 2, 3, 4. Okay, so double flat, flat, natural, sharp, and double sharp. Okay, double flat is -2, -1, 0, 1, and 2. Yeah, that should be okay. Yeah, okay. And I think this is actually a good way to do it. In effect, we're saying implicitly referencing the key is the same as writing the note out directly. That feels like a good, true thing. Okay. And I would say that takes us where we're sort of it's sort of a natural combination. We're supporting the major keys, we're supporting all the notes, we're supporting notes in the major key. And if you don't know the key, we default to C, which is no flats, no sharps, and no problem. Notes implicitly, if they don't know it, I guess that's down here. If it's not marked as a note to modify, we would just return no modification and we're done. Okay. Adjustment for I want to say adjustment half steps. Okay. And in the accidental, how's that? I think this could almost just be half steps. Okay. So flat is 1/2 step lower, sharp is 1/2 step higher, and similarly for the rest. All right, let's deal with the renames. Okay, so we add support in note for adjustments for any accidental. And I guess the renames are part of that. That's okay. Whew. All right, how's our to-do looking? I think I'm behind. Make note, understand key. Okay, we've done that. That's good. Okay, now Parsons code for a whole file. Right, so the format, let's go back up. So file structure, the real thing is a tune. It's a header and a body. The header starts with an X. Oh, I hate this should. And it's like it should be must if that's what it needs. It needs an X. It needs a title. And it must have a K field, a key. Okay. Now the title, you can actually have multiple title lines, but the first one is the real title or the title you're calling it. The others are like alternate titles. All right, the tune body follows immediately after. Fields may be used inside the tune body. Yes, very annoying as well. It's legal to write a tune without a tune body. Okay, so that's fine. All right, so there's an optional header, which is more fields. Okay, I want to create a file that I don't want to mess with this optional header. I just want to start with the tune header. It means I need an X and a title and a key. All three of those must be present. There can be a bunch of other things. And then followed by lines of music. And I don't know, blank lines, I'm not sure where they come in. Separate tunes, free text, and header. Okay, line breaks can... Yeah, line breaks are a little complicated, but if I find an empty line, I think that will end a tune. I'm going to go jump way down. They have a bunch of examples. Section 13. Yeah. Okay. Yeah, these I'm seeing. Okay, so here's the header. There's a version number and this stuff. This version number might be present no matter what. But then a blank line and then an X, a T, blah, 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 K, and then a bunch of notes separated by a blank line from the next one. There's no blank lines within a tune. Okay. Something pretty horrible, or there's a lot there, but it doesn't allow blank lines in there. So this one has some words and musical notes. Z is a rest. These are notes. Okay. Spaces inside, no problem, but no blank lines. Okay. Yeah. So, okay. Monteverdi, early opera composer. This might be from the first opera for all I know. Right. So at our high level parsing, we've got to handle X, we've got to handle T, we've got to handle K, we've got to handle notes, and then we got to handle blank lines. Okay, so that gives us some stuff to look for. I don't know. The parser is starting to feel a little unwieldy to me, even as it is. Like, I don't know, we got 100 lines here, 150 lines, 180 lines. Notice most of this is not parsing. It's all about how do I make keys and how do I make notes and stuff like that. Maybe that can pull out. We might be better off out. All right, but let's find the key parser. Okay, let's find make key parser. All right, so the key parser itself is matching K, A through G, match set, blah, blah, blah. Okay, let's make a index, which is the X. I think they called that an index. Here's the big one. X is reference number. Okay, so it finds a unique reference number, only one X per tune, maybe empty. I don't know if I want to handle that just yet, but okay. They don't have to be unique, apparently. Right, yeah, it's used to assign a unique reference, but nothing's saying you must be unique. So, it's yeah, another one of those, like, I kind of wish it were a little different, a little more picky would be better. And actually, this is one of these things that people can screw up. So, right. So X colon, I guess we're not really doing anything which should be unique, but it's not necessarily unique. But if there's no X field, you don't start your tune, so we know there's got to be that. Okay, so let's match an X reference number. It doesn't even tell you it has to be reference number is a positive integer. Okay, so well, let's define an X. Okay, so key to accidentals and key parser. Let's make a reference X reference parser is cbind of I think it's going to be just, well, let's do the real thing. It's really optional int. Okay, it said it didn't have to be there. Whoops. All that banged. Okay, so we're promising there'll be one. I think that's okay. And here we're going to say, I guess this is x reference parser. X reference parser equals make x reference parser. Okay. Which is going to look a lot like our K parser, wherever it is. You can see why I'm whining a little. Okay. Let's just steal its body and we'll deal with it. Okay. This make x reference parser cbind int optional. Okay, x ref parser is, well, it's an x followed by a colon followed by optional digits, one of 0 through 9. Okay, so it's going to be a positive integer, and we'll make this be a method build x reference. Okay, and we'll bind this to xref parser.parse. Okay, build x reference is a lot like build key as far as function shape. Okay, and this is 0 or more characters. So its contents is digits is an array of character. And we want to produce an optional int. Okay. So if we take dot count is 0, then we're just going to return nil. They didn't give us any digits. We're a nil. Okay. Otherwise, we're going to take the digits dot I don't know if we can map them. Map each one to its integer. Okay, let's do Swift character to digit. Well, that's actually what we want, isn't it? Int of string of car. That's the one character one. I guess this is probably the easiest real way. Convert them to strings. A little clunky. This isn't something you're doing all the time, though, so I don't think it's going to be an issue. All right. I think that should build. So here's what I know. Cannot convert this. That should be int. Okay. The build works. Nobody's calling it. I forgot to create a test. Can you believe it after all this time? Okay. We will create a test next time. And so we need to parse the X field, add a test. Okay. We need to create that test, create the field, check both cases, either empty or digits, and move on to the other parsers. So that is parse the the first T field, and parse the notes line. I'm not quite sure we do that, but once you've done those, you can parse one song, and then let's say parse one song, and then parse multiple songs. Okay. And when you have that, then you've got enough information to start understanding this. So we will pick up there next week. It's, let's see, Monday, whatever the date is on that. Is that the 18th maybe? Monday, 1 to 3:30 p.m. Eastern Time, or 6 to 8:30 p.m. UTC. And I'm sure we'll be well on our way in parsing. I expect to be parsing one whole song by the end of the day, maybe all the songs. And we will go from there and start doing this analysis once we finish the parsing. All right, thanks for joining. I hope I catch you again sometime. Take care, and bye-bye.